Welcome back guys with a brand new video, and in this video we are diving into the fascinating world of crossover current circuits. Ever wondered how these circuits manage currents efficiently while crossing paths? Stick around because we are about to unravel the mystery. First things, what exactly is a crossover current circuit? Well, it's a configuration, as you can see, that allows multiple currents to cross paths without interfacing with each other, and this is incredibly useful in various electronic applications, especially in scenarios where different signals or power sources need to be changed independently. Let's break it down. In a typical crossover circuits, we have three separate paths of currents here. These paths intersect at specific points, and the circuitry ensures that currents following through these paths do not interfere with each other. As you can see here, that every separate path is following but not interfering with each other. And crossover, one common application of crossover circuitry is in audio system, particularly in speakers. Different frequency ranges like high, mid, and low are managed separately to optimize sound quality. Crossover circuits efficiently split the incoming signal into these ranges, directing them to the respective speaker designed to handle each frequency. For example, if we consider here that this one is our a low frequency signal, this one is our mid or high frequency signal, or this one is our mid frequency signals. So which we require to directly connect with this, and a potentiometer will be used, that which path we are using and which range we have to use. As you can see the working here also, that's how it's work. And now let's see it in action. I have here practical setup to demonstrate how a crossover circuit manages multiple currents crossing paths without references. As you can see, the clever design of the crossover circuit ensures that each current stays on its designed path, allowing for simultaneous operation without disruption. You can see here that here we have this one. In all the paths have the same single input, but as the name of the circuitry is crossover, it means they are not interfering with each other. You can see here this is gradually decreasing as moving toward this path. This is all depending upon the charging and discharging of the resistor of the capacitors and inductors, and this is crossovers to this and this branches. As you can see here, this is gradually becomes there is no current passing in this branch, and it is moving to both these branches. And you can hear the graphical representations here, so that's how the um, uh, waveforms is changes across these. This is for the first one, as you can see here, that it is increasing gradually, and this is for the second one, and this is for the third one. And here you can see that there is no current passings or voltage passing across in this path or this branch, so it is zero. There is no voltage or current passing across the path 2, it is become zero. As gradually it's passing across the path 2, it's increasing, the waveforms is increasing, and so we can easily understand the working principle of the crossover circuits. Now if we talk about the designs, that how we have to design the crossover circuit, you can see here simply it's a combinations of inductors, capacitors, and resistors. We have to only memorize the method, or you can say circuitry, that how we have to place that. First it's a inductor in first branch, and in the other two branches we have the capacitors in the start. Then we have a capacitor branch that is in parallel with this, and but in other two branches here we have the inductors. Then, and because you can see here that it is a little bit opposite of these two branches, yeah, then you can see here that here we are using inductor, then in both these branches we are using capacitors. This branch and this branch are you can say vice versa of each other's or opposite of each other's. Here we are using inductors, and in this branch we are using capacitors only, and in this branch we are using inductors and resistors and capacitors. Like this, inductors will be replaced by capacitors and capacitors will be replaced by inductors. And this, you can say, what about this branch? This is the summation of both two these branches, this one and this one. This one is, you can see here, capacitor, inductor, capacitor. Here this one is inductor, capacitor, inductor, inductor, capacitor, inductor, and the resistance will be common in all the three branches. Here we have the designs of the crossover current circuits. And to sum up, crossover current circuits plays a crucial role in managing multiple currents efficiently, whether it's in audio system, power distributions, or other electronic applications. Their ability to control and direct currents without interference is what makes them indispensable in various industries. And that's wrap for today's explorations into crossover current circuits. I hope you find the fascinating this find found this fascinating as I did. And if you require any type of assistance in electrical and electronics projects, you can ping me a message on my WhatsApp number, and also you can visit my Upwork and Fiverr profiles. Thank you so much for watching the video. Please like the video, share with your fellows, and subscribe my channel. Thank you so much.